Hi, my name is Vahan Dawoodian. I'm a physics experimentalist for 34 years, and today our topic is manned space travel, and I will explain step by step. And in fact, this is my creation, my logo, and if you click over here, you can see all my 72 theories, and it says unique physics concept, and by Vahan Dawoodian, how to promote the science. And this is my email, vahandawoodian1948 at gmail.com. And if you click over here, you can see all my videos. And this is so important because the humans were dreaming about going into space thousands of years ago. And finally, in 1960, that happened. And then it started with Yuri Gagarin, the Russian husband. And you can see in this picture, this was taken in International Space Station, and you can see this astronaut is upside down. The reason why the entire International Space Station is falling, falling free. So that's why whoever is inside the space station, they fall free. I show you one little demonstration. If this is the Earth, you can see if this is the Earth and this is the moon, and moon is doing the same thing. You see, the moon is falling, but the gravitational pulls always toward the Earth. At the same time, this has the velocity in it, a straight line, then it's going round and round and round and round. So overall, entire solar system, you can see, I show you here. See, of course, this is a small picture, but you can see we have the Earth, we have the Mercury, and then we have the Venus, and then Mars, and the Saturn, all this Neptune. You can see everything falls around the Sun, and in fact, some of them are a little bit more elliptical, like Neptune and Saturn and Mars, and some of them are less, like Mercury, and then Earth is more elliptical. But overall, that is the concept. They fall free around the Sun. So, but overall, if the acceleration is 9.8 meter per second, so what happened? You have exactly the same, acceleration. So they cancel each other, and then they fall free, and then you feel like you're weightless. So this is so important that this has been around almost 20 years, and this was breakthrough in science, International Space Station, because this is exactly like a planet for us, because we can do experiment, we can do everything in International Space Station, but it was very costly, very difficult, but finally we did it, and I'm hoping, in a few years, maybe it's going to be retired because it's getting old, but overall, this was so important, and they played a very important role in the history of mankind, because all the scientists, Russians, Americans, Europeans, even China, they did a lot of experiment, and then they improved everything in science. And in fact, this is the space suit, and it is so important that in space we are exposed to radiation and the microgravity, and then flying debris everywhere, and then the chances are they're going to get hurt. And this is like 7 layers, and in fact it has a ventilation inside because it's going to be so hot, and then also sometimes gets so cold, so it does everything. And then it has oxygen, and then you can see this is like a backpack, and then it can do everything. But I have to explain about the International Space Station, and in fact the idea was we have to take this in a space, component by component, or module by module. That's what happened, because it's impossible. Such a huge structure, you send it in space, it's almost impossible. So what they did, they just installed, gradually 1 module, 2 module, and all the way, and then this was a huge thing. But the thing is, this is exactly follows the Kepler law. exactly like, Mercury is going much faster around the sun, then comes the Venus a little bit slower, and the Earth is a little bit slower, goes all the way to Neptune, we take 164 years. And this is exactly the same concept, and imagine this International Space Station is going around the Earth almost 90 minutes. So imagine how fast it's going, because it has to defy the gravity at the same time. It has to keep the orientation and exactly the same level. And in fact, they come up with a fantastic idea for the, International Space Station. If you recall, about a few months ago, I talked about satellite. They have thruster. So if they go out of orbit a little bit, they can use the thruster, and they have propellant and things like that. But in International Space Station, it's not like that. They use the genius idea. They have huge, gyroscope, and this exactly the conservation of angular momentum. So instead of using propellant for this International Space Station, they used huge, gyroscope, and that velocities, their RPM is so fast. So what they do, they can reorient the, International Space Station if it's a little bit off course, because always it has to be the same distance. It's like 250 miles above the Earth. But imagine, even 250 miles above the Earth, we need oxygen, we need everything. We need food, and then the microgravity is so difficult. I will explain as we go. Then what are the consequences of being exposed to microgravity? And in fact, this is amazing. It's got 16 pressurized modules, and then 6 science lab, and then a lifeboat, just in case if something happened, they have to, abandon, because unfortunately in space, especially around the Earth, there are millions or billions of debris. Some of them are small, some are, but imagine with that velocity, if they hit the space station, that's going to be so dangerous. And then, of course, it has protected layers, but imagine always they have lifeboat. If something goes wrong, they can go. And this was launched in 1990, gradually they built everything. And imagine, this is like $200 million. $200 million is a lot of money, and they have everything on board. And the reason why I mentioned this is like a planet, because the humans are dreaming to go to the Mars and other places, and this is so close. And then we don't have to go to a different planet. We can do all the experiment here, because you can see microgravity is 100%. We can do experiment, whatever we want, we can do. And in fact, in 2003, something amazing happened. One astronaut, his name is Don Pettit, and then he was doing some experiment in International Space Station, and he had like grains of, salt. Then he realized after a few minutes, they clumped together. And that was the consequences of microgravity. And this solved so many problems, how the planets are formed, because they were thinking, when the small things, pebbles, or, small asteroids, or, anything comes together, what happened when the planet is formed? Well, of course, it takes millions or billions of years for the planet. And what Mr. Don Pettit did, he said, this is the way it is. Then it was approved, and all the scientists realized this is what happened. When they asked, when those, little pebbles and, those little, debris come together, almost half a mile or 1 mile, and then the gravity takes over. Because, each element, each particle in space has an electrical charge. So what happened, that electrostatic forces, they come together, and they become like a big asteroid almost. Then gradually they attract more. This is exactly what happened in Jupiter, which is the biggest planet. They attract everything. So this was amazing that this was, happened in International Space Station in year year 2003. And in fact, they don't have to have thruster, like I said, they used as, huge gyroscope, and the angular momentum is so good, and it's a conservation of angular momentum, which, redirect the International Space Station in the course. So since we had this, there was so many, they took some, like insect in space and so many other things. But unfortunately, the problem is microgravity always has a consequences. Even insect could not, reproduce, and the humans cannot reproduce. That's another problem because of microgravity. But we can have all the experiment we want, so we can do whatever we want in a space station. And like I said, there's so many experiments I will mention later, step by step. This free fall is amazing concept. Let me put this poster up, you can see. I did this 25 years ago. Well, of course, now I had to change the name. Manned space travel is acceleration due to gravity in different inertial frame of references. I calculated with unprecedented precision, with a great precision. You can see on the moon, the fall time is 1.6 meter per second. On Mars is 3.7 meter per second, and on Earth is 9.8 meter per second. On Jupiter is 24.8 meter per second. So the free fall or anything, has to do with the gravity. As you know, Moon is 1/6 of Earth. Mars is almost like almost say half or 1/3 maybe. But see, Jupiter is amazing. We can jump on Moon. You can jump on the Mars, but on Earth, no, you cannot jump. You can jump a little bit, but on Jupiter, you can hardly walk. It's because of this gravity. So you can see I calculated all the way till like 7 seconds. Well, of course, I don't want to waste that much time. And this is amazing. Whether you drop something, let me show you. Whether you drop something like this or roll it the ramp, the proportions are exactly the same. So the position is half of the acceleration times time square. And Galileo did that, and then I have explained this in 2003. 2022, and it was May 19, 2022. You can watch the 4 videos as like 2.5 hours. It's called the free falling objects, and then you can see exactly what the free falls are. So this is the concept of the free fall, and like I said, they all follow the same rule, whether you drop the ball like that, whether you roll it, the ramp, it's going to be the same proportions. And this is another poster which is so important. This is showing how the humans, how we evolved from this, space travel. I remember, I don't know why, I remember the exact circumstances. I was 12 years old, I was 7th grade. Then I came back from high school, and then I realized Yuri Gagarin was in space. It was in April 12, 1961. So I was exactly 12 years old, and this was breakthrough in science because he was in space 108 minutes. And I remember he wrote a note later, Mr. Yuri Gagarin. He was taking a note, then the pen fell. And he realized at that moment, what great moment for the humans, he was doing free fall. And after that, the first American, astronaut was Mr. Shepard, and then he did that in May 5th, 1961. And you can see this is the capsule he was in, and then it was called Vostok, and then after that we have the June 15, 1963, Mrs. Valentina Tereshkova, and then she was the first, women in space, and gradually we had this, space shuttle. I remember Apollo 11, had to land in the ocean, and then they realized they can use this, which is so good. And the point is, this doesn't have any engine, it lands, but it can be reused over and over again. And the breakthrough came in, like I said a few minutes ago, this was International Space Station. But unfortunately, I heard that, in 3 years it's going to go out of commission because it's getting old. And I'm hoping we can replace it with something else. And this was the first Chinese in space. It was in 2003. His name was Yang Liwei. And that's what happened. Well, of course, this is the picture of Yuri Gagarin, and then he studied engineering, and he was a good pilot, but unfortunately, he was so young when he was killed in an accident. And then this is a huge picture of Space Shuttle. You can see that is amazing. This goes with the, everything. So it goes into space. That's the reason why they can come back. This poster is so important because, let me tell you why. Because humans were dreaming going into space maybe thousands of years ago. But like I said, everything started in 1961, Yuri Gagarin. And imagine, these are the probes, they call it, before the humans go in any, planets, they can send this probe. Some of them took like many years to get because of, vast distances and things like that. Like I give you one example. This was a mass spectrometer, Cassini. Imagine this went to this Saturn and then could analyze the atmosphere, can analyze the composition of everything, the soil and everything else. At the same time, like this one shows in the Mars, they have a scoop. They can scoop the rock. They can scoop the soil, and then at the same time, this is like a moving lab. So they can analyze everything to see what the compositions are, because the rocks, in fact, shows that they had, water in the past. But, we cannot tell because this is extremely important. Mass spectrometer. And in fact, a few months ago, I had this. That was great success. So many people watched, and then they emailed me. They love this idea because this is the only way we can explore the different planets, or you can even colonize a planet. Now, this is what happened. So, but I had one picture which is so amazing. You're going to love this. This is the picture was taken from Mars. Well, of course, we haven't been there yet, but I'm hoping by, maybe 10 years, which I'm not going to be alive, I don't know. Hopefully, they're thinking they can be on Mars. So you can see this was taken in the winter, and this was taken in the summer. You can see this blue blob right there, see, because it's melting. And this is called, neutron and gamma ray detectors. They are extremely good, and it shows that, you don't even have to have water in planets. You can even have, ice like this, then we can take care of everything. Well, in fact, my idea is sometimes, we are thinking that, we have to have oxygen. No, when we go on Mars, there's no oxygen. But, the atmosphere is so thin that, atmospheric pressure is so bad for the humans, where we can decompose the, carbon dioxide and get oxygen. But it's very difficult, to get, water in space. A few minutes ago, if you remember, I talked about, International Space Station. On a lab, you can do, hydrogen and oxygen, but, running electricity through the water, and then that's so easy. And then you can see the proportion is 2 to 1 because you get 2 hydrogen and 1 oxygen, and the gas is collecting up there because of buoyancy. But in space, it's not like that because the International Space Station is free falling. Well, of course, they had to decompose the water to get the oxygen because they have to breathe oxygen. Well, what happened because there is no buoyancy there, so those bubbles of the oxygen stick there. So what they do, they came up with this genius idea. They have the centrifuge, so they can rotate it as much as possible. So what happened? Everything goes to the side, and then they can have the oxygen. Anyway, this is the consequences of being in space, because I can see sometimes, the astronaut, even, you're not in a planet, but like I said, the International Space Station, you're free falling. So they have to exercise because long exposure is so bad for the human. Even though you exercise every day, well, of course, you're strapped down because of there's no gravity, and then you always float in air. So you have to be strapped down. So you have to be confined, and then you can do exercise. And these are the consequences. You can see here, these are the normal human cells, red cells, but you can see in microgravity, they're distorted. So see this amazing, this is much different. Well, of course, this is not going to happen in a short term, like I said, in a long term. And these are the consequences if you are in space. It's called muscle atrophy, and then bone loss, and then the cardiovascular deconditioning. And imagine, no matter how you do it, these are the consequences in space. I mean, you cannot avoid it. Well, like I said, it depends on how long you stay in space, And then the other one is bone loss, and then loss of density, and it's called osteoporosis, because if the bones are not, dense enough, so they lose the density, and then it's due to reduced stress, because gravity is always pulling on us. So another thing is fluid shift. Then everything shift to your head. Then your head is so different. I mean, that is not, but when we are standing over here, then the gravity is helping us. Everything is going normal, and the heartbeat is there, and then the circulation of blood. But in space is entirely different. And then the fluid goes up because there's no gravity. Well, of course, there are more other things I have to mention. And, in order to colonize, we have to have so many things. Well, unfortunately, I don't like if we go to the, Mars, because Mars, there's no, atmosphere, the gravity is not good. And the most important thing for the humans to colonize is the gravity. And imagine, we cannot live in the moon because, we have to be in the moon. We have to reproduce in the moon, and then that human being, whoever, then they can adapt themselves. And imagine, a stage was set for the humans to come on Earth. We are the last guest on Earth. But imagine if the gravity is not good, it's not going to work. And the most important part is oxygen. On Mars, there is no oxygen. It's going to be difficult. We have to be confined in, small places, and then, the ground, or even lava tubes, but overall it's going to be a challenge. And the most important part is the relative distance from the Earth. Imagine, it's not easy to go to Mars because we can get to the Mars, but how are we going to come back? The fuel is not going to be enough. But you know what? There is a thing, scientists are working on it. I'm hoping in maybe 10 years we can do that, and then exactly what happened inside our sun is a nuclear fusion, and then if we can have that, we can travel almost, not saying 100%, speed of light. And I'm hoping that will happen soon because, with this ordinary thing we're traveling, it will take us years and years and years to get to, closest planet. But even though if we can find a planet like Earth, the problem is the fuel. How are we going to get there? We cannot have 95% fuel. Even 95% fuel in your rocket is not going to help because, the distances are so vast. Well, I'm glad, I mentioned these things. Well, of course, there's so many other things we can discuss for the, planet, how to colonize planets and things like that. But the humans are so good, and then we have done a good job so far. And like I said, International Space Station and so many probes we send it to different planets. Galileo, Cassini, so many of them. And each one of them are sending signals for us. We know exactly the composition, we know the atmosphere, we know, if there's a water and everything else they explain. But humans have to be there to see exactly how their body reacts. I mean, can we live there with that kind of gravity? So I'm hoping you guys love this, and then if you like it, you can subscribe it. And I always appreciate your patronage. You guys are so good because I'm proud of you guys. Your insight, your ideas, even your criticism, I like it, and always I take action. Thanks a lot for watching.